NumPy is the first data science library which we need to learn, and it has helped many other libraries to build, such as scikit-learn, Pandas, Seaborn, Matplotlib, and others. So what's the agenda of this video? What I will be discussing? So I will be discussing the understanding of NumPy. We will also create arrays with NumPy, and we will be doing it using three methods. The first thing will be transforming the list. Second method will be using built-in functions, and third one will be random data generation. After that, we will be discussing retrieve the information from NumPy array using the slicing and indexing method. And we will be discussing the basic NumPy operations, and then within the indexing and selection, we will be discussing about four different things in which grabbing the single element and even the slice of elements will be done. Then I will be also discussing the broadcasting selections, how we use the broadcasting in NumPy, indexing and selection of data in a 2D array will be done, and eventually we will be discussing about the conditional selections within the NumPy array. Then we will be discussing the other NumPy operations, as well as the vectorization technique will be discussed in the end. So let's begin. So NumPy is a Python library to create n-dimensional arrays, and broadcasting can be done with NumPy. So I have already told that we will be discussing broadcasting. We will be doing that within our code, and it has this built-in capability of linear algebra, trigonometry, random number generation, and statistical distributions. Most of it we will be covering in this video. So now NumPy arrays will be shown to you using three techniques. Let's see one by one. So first of all, you have to do this import NumPy as NP, and then we will have to continue with the other things. So whenever we will be requiring NumPy within our code, we will be using this NP now. And let's see. So executing this cell. So yeah, now NumPy is imported as NP. Now if I run this, a equal to 1, 2, 3, this is a list. I hope you know this, that in the data structure video I have already discussed that this is a list 1, 2, 3. Now type of a will be list, and print a will print these 1, 2, 3 values in a list. So this is the list class, right? So the type of this a, object is list, and then 1, 2, 3 is the value in it. Now, if I do this now, that array arra is equal to numpy dot array a. So I'm assigning the same values that are in 1, 2, 3 of a. So I'm sending those values into arra. Then we are printing the type as well as the values. So now it is a numpy array. So what I have done is I have converted that a, which was a list, into a NumPy array. So I can do this by np.array function, which converts a simple list into a NumPy array, right? Now within that, when we check the type, it will be NumPy array. It has to be printed like this, and the values are 1, 2, 3 without the commas. You can see the difference that this is a list and this is the array, right? Now let's talk about list of list. LOL is list of list here. So you can see that there are two square brackets that are starting. It means that there are multiple rows in it, right? So this is the first row, this is the second row, and this is the third row. Now if I print this LOL, this is actually a 2D list, right? So now this LOL, this is list of list. So I am defining list within list by doing this, right? So 1, 1, 1, 2, 2, 2, and 3, 3, 3. So these are three lists with the name LOL. If I print this, a list will be printed. You can see that there is a list having three lists within it. Now if I convert it into a NumPy array, and the same thing is done np.array LOL, it means that it will be printing the array version of it. So you can see that this is a 2D array where you can clearly see that these are the different rows within the array. So there is this function np.arange. It means that we want a list within 0 to 50 with a step size of 5. So if I print this, you can see the numbers are 0, 5, 10, 15 up to 45. Now 50 is not included, so it means that when we use a range function, this second number, is exclusive, so it will not be included in the list. Okay. Now if I write np dot zeros, so it is giving me a 1D array with 5 zeros in it. Okay. If I write np dot zeros 3 comma 4, now you can see that there are two circular brackets, right? So it is a 2D array, 3 comma 4, 3 rows are there and 4 columns are there. If I print it, zeros are there, 3 lists are there with 4 zeros in each, right? So within the array we have now 3 rows and 4 columns. Again, that can be done similarly for ones also. So uh, previously we were doing it for 0. Now you can do it for 1. Okay. So if you print this, it will be 3 ones, and similarly it will be 1 1 1 1 1 1 and 1 1 1, 3 rows and 3 columns. Now what you can see that all of these numbers are the floating numbers. So there is this dot with every number within this. So these numbers are by default floating numbers. Okay. Now this has to be taken care of. So whenever we are dividing something or multiplying something, so you have to know that whenever you are using this np.ones, it is giving us the floating numbers. Now if I do this np.linspace, it means that it will return evenly spaced 4 numbers between this range of 0 to 20, including the second number. Earlier what we were doing was that within that a range function, this 50 was not included. But if you want to include the second number, what you have to do is you have to use this linspace. So 20 will be included and 4 numbers will be taken evenly distributed. So if you run this, so you will find that there are 4 numbers, 0 and 20 is intact, right? 0 and 20 is intact. So the other two numbers are equidistant from 0 and 20. So you can calculate the distance. So 6.66 minus 0 is 6.66. So 13.33 minus 6.66 is equal to 6.66. 20 minus 13.33 is equal to 6.66. So it is all equidistant, right? So the two numbers are having the equal uh, difference every time. So again, when I do this 0, 4, 5, so what will be the output? Guess. So it will be 0 to 4. Simple counting will be there, 0, 1, 2, 3, 4. Why? Because we wanted 5 numbers between 0 to 4, including 4, and all numbers have to be equidistant. So the first and the last number will be same as in the list, right? So when we are giving this range 0, 4, so it has to be the first and the last number. Now the difference is 4 and we need only 3 numbers. So 1 minus 0 is 1, 2 minus 1 is 1, 3 minus 2 is 1, 4 minus 3 is 1. So every time the distance is same. Okay. Now there is this np.i function though. So this prints us the identity matrix. If you print this now, you will see that it is an identity matrix. So it is kind of a linear algebra function, but I just wanted to mention it here that so that you know that. Okay. Now let's discuss about the random distributions. So when I write this np.random.rand, random number is generated uh, by default between 0 and 1. So when you see this, so you will see that there is a number between 0 and 1. 1 is not included in it by default, right? So I have made a symbol here also that the first number of 0 will be included and 1 is not included. The second end is not included. So the number will be generating and you can run it again random number will be generated. Earlier it was 0.798 and this time it is 0.561. Again you run it, the number will be different and it will be between 0 and 1. So second way is that you can actually print a 2D random matrix also. So it is 5 comma 6. Let's see what it prints. So that so now you can see that there are 5 rows. Okay, there are 5 rows and there are 6 numbers in every row. So 5 rows and 6 columns, and every time the numbers are between 0 and 1, right? So now let's see that rand n. So n means here normal distribution. So I have written here also standard normal distribution, mean is 0 and variance is 1. If you print this function np.random.randn, so 5 numbers will be generated, and their mean will be 0 as well as the variance as 1. Okay, so this is how it looks like. Now you can do the same for 2D, 2 rows and 3 columns. So you can see this, right? Now if you want to do it for random integers, the function name is randint. So 0 comma 10 comma 3, it means that the 0 between 0 and 10, 3 random numbers will be generated which are integers. So if you print this now, you will find that there are 3 numbers between 0 and 10. 3 numbers are there. Again, if you do this 0 comma 50 and you want this 4 comma 5, so 20 numbers will be randomly selected from 0 to 50, and it will be printed. All the integers will be printed, right? So you can see that even there is duplicacy. This 44 is twice, but again we are generating random integers here in the size of 4 comma 5. So if you want that every time the result should be same, so if I want to run something and you are also running something, if we want that our answers are same, what you have to use is you have to use the seed value. So random dot seed, np dot random dot seed 42. So this 42 can be any number. It can be 1000, it can be 10, it can be 20, it can be 100. So 42 is a standard number. So np dot random dot seed 42, so it means that we are generating, uh, now we want to generate the numbers with the seed value of 42. So the every time same set will be used. Okay, now after that within the same block you have to write this np.random.rand. Now see this carefully. Within the same block I'm writing, I'm not segregating these two sentences. Now if I run this now, the 4 random numbers will be generated: 0.3745, 4012, and this last number is 0.5986. So if you run this, these exact two statements within the same block, you will exactly get these numbers. Okay, even if I run this again, every time the numbers will be generated same. Now let's say that I want to run this random.rand function again, but without the seed value. So you can see that if I run this twice, so both the numbers are different, right? So these numbers are different. Why? Because the seed value is missing now, and numbers can be different. So you have to take care about this. Now the next thing is that I want to do this np.arange 0 comma 25. Now if I do this, you can see that a range of numbers will be printed. If you want to print the list, you can do this. You can print this as a, and all the values are being printed 0 to 24. So a range is being defined between 0 to 25, and 0 to 24 are the numbers which are being generated here. So if you want to reshape this 1D array, what you can do is you can do a reshape, and 5 comma 5 will get the numbers in the 5 cross 5 state. You have to take care of one thing, that you have to keep this number accordingly, according to the size of this array. If you now do this reshaping with 5 comma 3 instead of 5 comma 5, now you know that within a there are 25 values, and you want to reshape it as 5 comma 3, so it will be error obviously, right? Because numbers are not matching. So 25 cannot be fit into 5 comma 3. How can 25 numbers be fit into 15 numbers, right? So you have to take care of this. Let me clean this code. Yeah. So now if I do this random dot rand int 0 comma 51 8, now what I'm doing is I'm generating a random array uh, between the numbers 0 to 51, and 8 random numbers will be generated, and it will be saved in rand array, and I'm printing that. So these are the numbers. These are the exact 8 numbers which have been generated between 0 and 51, inclusive of 0 and exclusive of 51, right? Now if you want to run multiple functions on this array, what you can do is you can have multiple functions, and you can get the results. Now if I do a max function on this rand array, so 43 will be printed, right? And minimum value is here 1, so 1 will be printed. Argmax is the so argmax returns the index of the maximum value. So so here it is 43, and this will return us 0, because 43 is at a 0 place. Now if I want to do the argument, now again this one will be checked, so it is at the third location, so 0 1 2 3, right? So this 3 will be printed in argument. Okay, now if I want to get the data type of this rand array, random array, so the data type is int64. It depends on your system. So this Google Colab is using a 64-bit system. If you, let's say that if you are working on a Jupyter notebook and your system is a 32-bit microprocessor, so what your value will be, it will be int32. So it depends upon your system, what is the background of your system and what is the size of the word size. So it is actually the word size. Int64 means that 64 bits are there in the word size of the system. So a dot shape, now a dot shape will return me the shape of the array, right? So array a was generated above. So you remember a was equal to a range 25, right? So I had generated this a range 0 comma 25 and 0 to 24 were there. So the shape of this array was 25 comma empty. It means that it is a 1D array, and there are 25 values in a row. Okay, now if I do the reshaping to 5 comma 5 and I print that, so I will get the values in this form of 5 cross 5. There are 5 rows and 5 columns. So if I get the shape of a, now it will be 5 5, right? 5 comma 5. So if I want to reshape it to 1 comma 25, it means that I want a single row with 25 columns in it. So there are now you can see that there is a single row, but now it is a 2D, right? It is a 2D array. So earlier it was having only 1D space, right? There was this only one bracket. Now there are two, so it means that it has taken this into account, that while reshaping it is having one row and 25 columns. So this is a 2D matrix now, having one row. Okay, now let's talk about indexing and selection. So there will be four things which I will be discussing now. Indexing and selection. So grabbing single and a slice of elements will be done. So grabbing single element and a slice of elements will be done. The broadcasting will be done. We will be discussing about the indexing and selection in 2D. We will be also doing the conditional selection. So let's discuss about the grabbing elements. Let's grab some elements from the array. Let's say that I am generating this array of np.a range 0 comma 15, and it will be printing 0 to 14. The numbers will be printing from 0 to 14. Now if I get arr 4, what will be my output? You are correct, so it should be 4. So what if I do this 4 colon 9? So it means that 9 will not be included, but 4 5 6 7 8. So 5 numbers will be printed. Okay, yeah. So 0 colon 4, it means the first element will be taken, and till 4 it will be going, but without including the fourth location. So the answer will be 0 1 2 3. Okay, now if I do this, colon and 4, so we are not specifying the rows, right? So only the columns are there. So it means that it has to start from the beginning, and it has to go till 3, because 4 will not be included. So arr 0 colon 4 as well as arr colon 4, these are actually same, because the output is same. Now if I write this arr 9 colon, it means the column number is not given, so it has to go from the ninth location till the end. Okay, so 9 10 11 12 13 14, so all the numbers are printed from 9 till the last number. So let's do some broadcasting now. So let's say that I want to write this array 9 colon equal to 100. It means now that from 9 till end all the values will be replaced by 100. So if you print this, so 9 to 14 are replaced by 100, right? So now if I do this np.a range 0 to 15 array, it means that 0 to 14 are being restored. Now if I want to, let's say, slice the array. So if you want to slice the array, you can do this by slicing array equal to, I mean, this variable can be different. It can be abcd, or you can put your name in it. So array 1 to 6, it means that from 1 till 5 the values will be picked and it will be put into the slicing array. If you look into this, you will find that the numbers are from 1 to 5. Okay, you can print the array again. So the original array was 0 to 14. So one thing to notice here is that we have picked a slicing array out of the original array, so it is 1 to 5, and array is 0 to 14. It is not changing right now. So now let's say that I want to replace all the values in the array. So let's say that I want to replace all the values within the slicing array. So single column means all the values from beginning to end. All the values are being replaced by 100. And now I want to also print the original array. You will see that it is changing the original array. Now why? Because when we are doing the slicing, even if you have made a copy through the slicing, it is actually having a pointer that it was pointing to those five values when we made this slicing array, but the original values will be affected when you change the slicing array. So this you have to take care that if you want to do some programming using this slicing, maybe you can generate a copy of that array. Now if I generate a copy of that array, so arr copy, right? So if I print this now, my array, my duplicate array is now same as array. So if I replace all the values within the array copy as 100, now all of them will be 100, right? All of them 0 to 14, all of them are 100, but my original array is same as 0, 100, 100, 100, and then 6, 7, 8 up to 14. So you can do this when you want to change some values within the array. Before doing the slicing, maybe you can do the maybe you can make a copy of that array, so it will eventually help you save your original array. So let's do now indexing and selection in 2D. So array 2D is equal to this. So I am making a 2D array having 3 rows and 3 columns. So 1, 2, 3, 4, 5, 6, and 7, 8, 9. If I print this array, it will be printing this in the array form 1, 2, 3, 4, 5, 6, and 7, 8, 9. Now if I want to print the shape of this array, it will be 3 comma 3, right? So let's pick some values out of it. Now if I write this array 2D 0, what will be the output? Guess. So this is the array. We are printing 0 of array 2D. It means not just one will be printed, but the full, but my all first row will be printed. Okay, so if I run this now, so it is actually printing my first three values. Now, like similarly, we can do this. If I print this, it will be getting my last row, 2, right? Now, if I do this now, 1, 2 in the different square brackets and within the same bracket. So actually it will go to the one row and the second location. So 0, 1, 2. So 1 is this row and second location is this. Why? Because 0, 1, 2, right? So it will be printing 6 in both cases. So you can do any method to print the value within the array. So now 0 comma 2, it means within the 0 row, value 2 is 3. So 3 will be printed now, right? So this column 2 means it will be printing the first two rows and it will not be printing the second last row. Similarly, if I do this now, now column 2 was doing this thing that it was giving me these two rows. Now one column means it will be giving me 2, 3, and 5, 6 as the output. Why? Because one column means that it has to start from one location and go till the end, right? So it is not picking the zero value. So let's do the conditional selection now. np.arange 1 comma 11. Now if I print this, it will be giving me 1 to 10. Now if I do this array greater than 5, so it will give me a Boolean array in which false and true will be given according to every value, right? So if I do this bool array equal to a array greater than 5, it means that it will be giving me all the values and it will be saved in a bool array. Now this bool array can be used to get the values out of the main array, and all the values having true will be printed. So having the true value will be printed. So in this array bool array, all the values satisfying the condition will be printed. Similarly, if I can do this array array greater than 5 within the bracket. So again 6 to 10 will be printed without using the bool array. So you have got multiple techniques now to use this thing, right? The conditions within the array. So let's talk about the NumPy operations now. So let's again make a NumPy array from 0 to 9. Okay, now if I do this array plus 5, it will add 5 to each value. Okay, so the output is 5 added to each value. Similarly, subtract 2 from each value. Array plus array means add each value with each other. Array into array, multiply each other. Subtraction means subtract each other, right? So the answer is 0, array minus array. If I now print the array, it is unaffected. Why? Because we were not actually harming any we were not harming our original array. We were just getting the outputs based on some operations. Now array divided by array, it means now 0 will be divided by 0, 1 will be divided by 1. So all the values will be 1 except 0 divided by 0. So it will give some warning that invalid value is there. Now obviously 0 divided by 0 cannot be done. So that is why it has given us not a number nan, otherwise all the values are 1. Right. So it has not give us any exception. It has actually given us the output of the other values, but it has also given us nan, not a number, in case when we are dividing by 0. Now if I do this 1 divided by 0 directly, so it will throw error. Why? Because it is not doable. Now 1 divided by 0 is directly not possible because it is not a NumPy array. So division by 0 is a 0 division error, right? So if I again do this 1 divided by array, it means that 1 divided by 0, 1 divided by 1, so everything will be done. But 1 divided by 0 will again give a warning and give a infinity number, because 1 divided by 0 gives us infinity. Why? Because it is actually not doable. But so this NumPy will give us NN values and the infinity values accordingly, but it does not give a error. It does give us a warning, but yeah, I mean it gives us the values in terms of NN and infinity depending upon what the numbers are. So if I do this square root, it will give me the square root of each value. The sign values will be given, the log values will be given, even the sum will be done. So you notice that within the log also this is not possible. Log 0 is minus infinity. So it is giving us warning again, right? So that was not possible. Log 0 is not defined. And so it has given us minus infinity for log 0. So it is not defined. So it has given us error like this, right? So array of full. So the sum is done like this. If I want to do the mean, the max, everything can be done, the variance, and even the standard deviation. So all the things can be calculated by using these inbuilt functions. Now, if you do this np.a range 0 to 25 and reshape them into 5 comma 5, you will get that 0 to 24 are given, and this 2D array is being converted because of this reshape function. Now if you get the shape of this array 2D, you will get the 5 comma 5 again. Now if you want to do the sum, it will give you the sum of the full array. But if you want to do it row wise or column wise, what you can do is you can give this x is equal to 0 when given within the function of sum. X is equal to 0 means you have to do the sum row wise, and x is equal to 1 means you have to do the sum column wise. So these values are column wise and row wise sums. X is 1 is column, x is 0 is row. So take care of this thing when you will be doing this. Now let's understand this last topic of vectorization. So the agenda is to minimize the usage of loops. So what we will do is we will be implementing a small function. So we will be doing a small operation using the for loop as well as the vectorization method in Python. So we will also be looking into the time difference between the for loop as well as the vectorization method using the NumPy. So let's say that this is my array now, np.array 1 to 4, and this is my random array having this value. So a and b can be generated like this. Similarly, these numbers can be generated using this rand function. So this random numbers can be generated for 10 million values within the A as well as 10 million values in B. So random numbers are being generated within A and B. So let's do the comparison of time taken for the dot product of A and B vectors. Now that we have the values of A and B as two arrays, and we have all the 10 million values in it, random numbers. So we have to do the dot product, and we have to calculate the time also that is being taken to execute these two things using the for loop as well as the NumPy. Now we have to use this function time dot time, and you can read more about it, but I will give you a simple idea that the number, so this time dot time is actually the time in seconds since this time of 1 jan 1970, the beginning, right? So since the beginning of this 1 january 1970, the timer was started, and with every passing second this value is being incremented, and we use this function to actually get the values for how much time is being taken for our work to be done. So if I do this now, so there are two variables here, tick and talk, and tick talk is actually the time, the initial time and the final time, in a way that I will be subtracting both of them and I will be getting the time in milliseconds. Okay. So np dot product will give will take some time, right? So np dot dot, this is the dot product function within the uh, NumPy, and this will take some time. So talk minus tick into 1000 milliseconds will be printed. And similarly, if I do this multiplication of each value between the A and B, and I save that into the C, so the total sum of the multiplications will be added and I mean saved in the C. So that time is being calculated by this tick and talk, and within that for loop. Now let's compare the two times and let's see the difference between the NumPy operation and the for loop operation, and let's see the difference also. What is the accuracy of this NumPy? Okay. Now the vectorized version is giving us answer in 28 milliseconds, and the answer is 2499546.2026826087. And you can see that using the for loop also the answer is nearly same. In fact, only the last four digits are different here, and it is actually very small difference. And the time difference is, look, it is 28 milliseconds for the vectorized version, and using the for loop it is taking 6000 milliseconds. It is a very big difference. It is more than 200 times of difference. So that's all from my side in this NumPy. I hope that you have learned a lot about NumPy and all the operations, the uh, difference, and all the things that you need to work using the NumPy. I hope this video was helpful for you, and subscribe to the channel to watch more videos. There will be more videos coming up in this series, and lots of things to learn. Thank you.